Yes. Now, for combinations, does order matter? No. Okay. They're used when drawing for identical prizes, and order does not matter. Okay. It is not important. So, in other words, we're going to have less combinations than we have permutations. Okay. And I'll show you why. In the next example, it says count the combinations of two letters from the list A, B, C, and D. Okay. So, do you guys agree that A can be paired with both all three of them? A can be paired with B, A can be paired with C, and A can be paired with D? Do you guys agree with that? Yeah. Okay. What can B be paired with? C. Can B be paired with D? Can B be paired with A? It can be, but would that be considered a different combination? No. Why not? Weren't A and B already paired together up here? So we're not going to include this one. And then we're going to do C and D, C and B, and C and A. But which one of those, or which ones of those, have already been used, peeps? CA and CB. So how many total combinations are there? 1, 2, 3, 4, 5, 6. Do you guys see how there's 6 combinations? How many permutations were there, though?
9.
There's 9, okay?
Wait, how are there 6 combinations? Oh.
So, remember, combinations is where order doesn't matter. So, do you see how B and A is being used twice? It was used up here, and it was used down here. CB was used here, and BC was also being used. And CA was used twice over here and over here. So for permutations, you can list them using different orders. But for combinations, if any two objects are together, you can't switch their order and count it as a new combination. Okay? Now, we also have a formula to figure out combinations. So you're not going to have to make this list for every single one. Okay? What we can do for the list, right? Instead of the completely left out D, guys. There are 12 permutations. None of them count as combinations because D is being used with every single letter previously. This is apply the formula, and it's very similar to the permutation formula. Only when we write this C, we're dividing by an extra number, and it's R factorial. Okay? Xavier, did you have a question? For combinations, there is this R factorial that's being added to the denominator, okay? So there will be less, write this down, there's going to be less combinations than there are permutations. Okay, where N is the total number of objects that you're choosing from, and R is the number of times that you're picking them. R is the number of times that you're picking them. Or, like we said it previously, the number of choices, okay? All right, so it's going to have N factorial, so your larger number. Let's see this formula in action. You order a sandwich at a restaurant. You can choose 3 side dishes from a list of 8. How many combinations, so order's definitely not going to matter, of side dishes are possible, okay? So how many side dishes do we have to pick from? 8 in total, right? How many are we actually picking? 3. And this is a combination. So it's going to look like 8 and 3 with a C on it. Do you guys see that? The number in front should always be bigger or the same as the number next to it. Okay? So 8's bigger than 3, so we're good. So we're going to say this equals factorial on the top, so it'll be 8 factorial up here. over 8 minus 3 factorial. This is how we would write a permutation. But combination adds what in the denominator? An r factorial. What's r in this case? 3 factorial. Okay? So this is going to be 8 factorial over 5 factorial times 3 factorial. Calculator time. Those of you that don't have the factorial button on your calculator, you're just going to have to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? 8 factorial divided by 5 factorial and then times 3 factorial. I got 56. You got 56? Okay, 56. So for those of you that are struggling to put in your calculator, sometimes it's easier to write it all out and start canceling out. So let's write it out. We have 8 times 7 times 6 times 5 times 4 times 3 times 2. Do you guys agree? I'm not going to put times 1 because 1 just, it doesn't really, we don't have to really put it. Then it's 5 times 4 times 3 times 2. And then 3 factorial is 3 times 2. Let's start to cancel. 3 and 3, 2 and 2, 4 and 4, 5 and 5. Do you agree that 6 is going to cancel with 3 times 2? So we just have 8 times 7, which gives me 56.
Why does it not get 1?
Technically, yes, you should be adding 1 here, but if we multiply by 1, is it actually changing our problem at all?
So if
Yeah.
we're plugging,
Yeah.
if we're plugging in the 5 factorial times 3 factorial,
Yep.
we do each of them separately and then we multiply the things together? Or
So that's a good question. Okay, so the 6 I canceled out with the 3 and the 2. Because you see how 3 and the 2 cancel with 3 and the 2? So we still have a 3 and a 2 left over, right? So this 3 and 2 canceled out here, and this 6 canceled out with the 3 times 2 down here. Because 3 times 2 gives me 6. Okay? Good questions. Any other questions, guys? Christian?
Do you have like some sort of thing that you did last time?
For combinations?
Yeah.
Unfortunately, I do not. I'm sorry, Christian. Good. Any other questions? Yes?
Since we have a calculator, do we have to do that?
Since we have a calculator, do we have to do that? No. So if you just get 56 from here, I am totally cool with this. But if you're struggling with putting it into your calculator, you may have to do this. And I just wanted to show you that I can get it 2 ways.
So like on the test, we don't have.
You don't have to list them all out. No. Okay? Good questions. Anything else?
How do you know if you did it wrong? Like, let's say if you forgot parentheses, how do you know? Is it just going to be a really big number? You're never going to get a really big number?
Not necessarily. You could get big numbers for combinations, but maybe find the permutations. If you found 8 permutated 3 times, you'd find that like 216 is even bigger than this, and you're going to know, okay, I did something wrong. Okay, because combinations should always be less than permutations.
Isn't it always also going to be a whole number? You can have like 1 or something.
Yeah, but they were getting 2016, so that's still a whole number. But yes, you are correct. You would get a whole number. Okay. A yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? Guys, does it matter the order in which they put our photos there? It does? No. All they want are which 2 photos? The one of us and the one of our friend, right? Does it matter which one comes first? If order doesn't matter, what does that tell us? It's a combination. So we're going to put a big C here. What's the total? What's the total objects that we have to pick from? 14 photos in total. And how many are we picking? 2. So it's 14 combination 2, okay? So we're going to put 14 factorial on the top over what goes in the denominator? 2 factorial and
14 minus 2 factorial.
which is 12 factorial. Do you guys see that? I did 14 minus 2, which gave me 12 factorial, and I added my r, which is 2 factorial, okay? So how many combinations do we have? Let's check it out. This would be 14 factorial divided by 12 factorial and then times 2 factorial. Did you guys get 91? Perfect. 91 combinations. You could also do 14 times 13 and then divide it by 2. That'll also give you 91. Because we know that after 14, 12 factorial and beyond is going to cancel out. So you just have 14 times 13 and then divide it by 2. Carlos.
Are we looking for probability?
What's that?
Are we looking for probability?
Oh, you are. Whoops. So, we're doing what is the probability that the photo and your friend's photo are the two placed at the top of the... One favorable outcome is the one chance that ours and our friends are up there out of the 91. So the probability of both photos is 1 over 91. If you wanted to convert that to a percentage, it would be 0.011, which is 1.1%. The number of favorable, well, let's think about it. They have 14 photos to choose from, right? And of those 14 photos, picking any 2 of them, there's going to be 91 combinations, right? There's only one combination we care about, and that's where our photo and the photo of our friend is chosen, right? That's one of the 91 combinations that are total, okay? Now, if it was permutations, we could have flipped the order. So we could have had our photo first and our friend's photo second, or our friend's photo first and our photo second. That's 2 permutations out of the total number of permutations, okay? But in terms of combinations, there's only one, all right? Thank you, Carlos, for noticing that. Xavier, you were going to say the same thing? Okay. All right. Your teacher randomly chooses 2 out of 18 students to give an impromptu debate on freedom of the press in high school newspapers. What is the probability, so again, we have to calculate probability here, that your teacher chooses you and your best friend, okay? So, guys, let's start with the number of favorable outcomes. What is the number of favorable outcomes here?
1.
Why?
Because you only have one less friend than you.
Yeah. There's only one combination where you and your friend get picked, right? If order doesn't matter, right, there's only 2 of you, you can only get picked in one way, which is with you and your friend. So the number of favorable outcomes is 1. So whatever we get for the total number of combinations, we're going to put that as our denominator, and that'll be our probability, okay? So how many students are there to pick from? 18. And we're combining them with how many are we picking? 2. So 18 picking 2. We're going to do 18 factorial over 16 factorial times 2 factorial. All right. 18 factorial divided by 16 times 2. 153 So this is the total number of combinations. So the probability, or P, of both getting picked is going to be 1, the number of favorable outcomes, over the total, which is 153, which is about
0.01% if you round up.
0.0, oh yeah, 0.007, so it's 0.7%. Or you could just leave it as 1 over 153, okay? So how I was in the quiz, right, where I really didn't care whether it was a fraction, a percentage, or a decimal, I'm the same way going forward, okay? You can leave it as any 3 of these, and I would be totally okay with it. Yeah, if you round it, round to either the tens place as a percentage, or the thousands place if you're gonna leave it as a decimal. Yeah.
I tried calculating that and got this somehow.
Yeah, so 10 to the negative third means move it over 3 spaces.
So round to the tenth
Oh,
place.
because that rounds to itself. Okay.
For percentage, yeah, rounds to the tens place. Jaden?
How'd you get one?
Number of favorable outcomes? Okay, so there are 18 students to pick from, right?
Yeah.
The only combination that we want is us and our friend, right? That's only one combination out of the 18. Or out of the 153 in total, right? Because it could be us and someone else, but the only one that we care about is us and our friend. Now, even if our friend's picked first and we're picked second, it's a combination, so the order doesn't matter, right? So the number of favorable outcomes is still 1, okay? Any other questions? Yeah.
I don't know why, but in my calculator, when I put 1 over 153,
Are you getting like something times 10 to the negative third?
yeah,
Yeah. So that's just, it puts it into scientific notation.
so how would I get it to that?
Well, you write it out, right? I think it was like 0.65, and then maybe like 3.5 times 10 to the negative third, right? Just move your decimal 3 places to the right. So it's going to be 0.0006535, and then you round it 0. Hold on. It wasn't written like that, was it?
It was 6.535.
It was 6.5 times 10 to the negative third, right?
Yeah.
So we're still going to move it 3 spaces. I'm moving it 3 because of this negative 3 here, okay? So 6 point. So I move it 3 spaces, so I should get 1 less 0 here. So it's 0.005, and then you know that you have to round that, so it'd be 0.007. Okay? All right, last example, peeps. Evaluate these two. 10 with a combination of picking 8, and 24 with a combination of picking 10. These are on the board for you guys to check. I want you guys to discuss, talk about what you did in your calculator, see if your neighbor has a way that they did it. Discuss it, and then we'll go over them. NC8, Mariana.
So, I put 10 over 2 factorial times 8 factorial.
Mm-hmm.
I did 10 minus 8, so that's how I got the 2.
Okay.
And then R is 8. And then if I look up there, I got 45.
Very good. And so, can anyone walk me through 24C10? Xavier?
So I did 24 factorial.
Yep.
Over 14 factorial times 10 factorial.
Yep.
And I got 1,961,056.
Let's go. Those are both correct, okay? Now, before